Okay, Wildcats. Today we're looking at solving systems of inequalities. Steps to solve systems of inequalities. Step 1. Put the equations in slope-intercept form. When you multiply or divide the inequality by a negative number, the inequality symbol flips. Step 2. Graph the first inequality. When y is less than, it's dashed line and shaded below. When y is less than or equal to, it's a solid line and shaded below. When y is greater than, it's a dashed line and shaded above. When y is greater than or equal to, it's a solid line and shaded above. Okay. Step 3. Graph the second inequality. Again, when y is less than, it's a dashed line and shaded below. When y is less than or equal to, it's a solid line and shaded below. When y is greater than, it's a dashed line and shaded above. When y is greater than or equal to, it's a solid line and shaded above. Okay. A little note, if the regions do not overlap, then there is no solution. If you would, update your notes. Okay, now your notes are updated. Let's take a look at the example. Okay, solving systems of inequalities. Example 1. Graph the system of inequalities and then select the coordinates of 2 points in the solution set. Okay, so when you have y greater than or equal to 1/2 x minus 2, to graph this is in slope-intercept form. So you start by graphing at the y-intercept, so -2. So you have a point at 0, -2. Okay. Now, slope is rise over run, so this tells us to go up 1 to the right 2. So up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Now, 1/2 is equivalent to -1 divided by -2. And the reason why that's important is this now we can go down 1 to the left 2. So down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay. Now, there's a line underneath. Okay, so it's a solid line. Okay. Now, I'm going to use highlighters for the shading, and you'll see why here in just when the example is done with. Okay, so I'm going to do this inequality in yellow. Okay, so it's greater than, so we shade above. So I'm going to shade above. Now notice I'm shading outside of the lines because technically this graph expands outside of what's on the grid there. Okay. All right. Now let's graph the second inequality. So here we start at the y-intercept is 5. So 1, 2, 3, 4, 5. I'm going to move these papers out of the way so I don't get highlighting on them. Okay, so we have point at 0, 5. Now we're going to divide this by 1. And the reason for that is because now this is, we know to go down 5 to the right 1. So we're going to go down 1, 2, 3, 4, 5 to the right 1. Let's double check that. Down 1, 2, 3, 4, 5 to the right 1. Okay, so down 1, 2, 3, 4, 5 to the right 1. All right. And I believe that's as many points as you can graph for that one. You could actually, I guess if you wanted to, you could actually go down 1, 2, 3, 4, 5 to the right 1 more. Okay. And let me make sure. You want to double check when you're graphing to make sure your points are lined up. Down 1, 2, 3, 4, 5 to the right 1. Down 1, 2, 3, 4, 5 to the right 1. Now, there's no line in these, so this is a dashed line. Okay. Now it's less than, so you shade below. Oh, as I knock the camera, let's not do that. Okay, so you're going to shade below. Now I'm hoping you see that the overlapping region is changing colors. Okay. And that's why I use highlighter, because it's really cool, because now you know that the solution is the overlapping region which changed color. Okay. Now, let me adjust the lighting a little bit there. All right, now the question says pick 2 points of the solution set. So basically, any point in this region would be a solution. Okay, so let's just pick this point right here. Okay, that's the solution. So that point is negative 1, 2, 3, 4, 5. So negative 5, 2. So that's one solution. So 0, oh, sorry, not 0. Negative 1, 2, 3, 4, negative 5, 2 is one of the solutions. Okay, we can go here, negative 2, negative 1 is another one. And you can keep going, but really I just wanted to show you 2 examples of solutions in the shaded region. Okay. All right, so go ahead and finish up example 1. All right. Sorry, I had to pick up a pencil, and here's example 2. All right. Solving systems of inequalities on journal page 23. Example 2. Graph the system of inequalities and select the coordinates of the 2 points in the solution set. Okay, now before we can graph this, we need to solve this for y. So let's come over here. We have x minus, and I'm going to put a 1 there, 1 y greater than 2. Okay, first step, we're going to subtract 1x from both sides. Okay, so then you have negative 1y greater than 2 minus 1x. We're going to divide everything by negative 1. And when you do that, the inequality flips. So now this becomes y less than, 2 divided by negative 1 is a negative 2. A negative 1 divided by negative 1 is a positive 1x. But we're going to divide that by 1. So we have the rise over run. Okay? And before I forget, I'm going to do the shading for this one in yellow. And I'm going to change highlighters. I'm going to change this to green. Okay? All right. I think. Sorry. I have a better green highlighter. All right. So to graph this, we start at negative 2. And we go up 1 to the right 1. So up 1 to the right 1, 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 up 1 to the right 1. But we know that 1 over 1 is equivalent to negative 1 divided by negative 1. So we can actually go down 1 to the left 1, 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 down 1 to the left 1. There's no line underneath, so that's a dashed line. Okay. Now, it says less than, so we shade below. So we're shading below the line. And move these papers out of the way so I don't accidentally highlight on them. Okay. Okay, now we're going to solve this inequality for y so we can graph it. So we have 4x plus 3y less than or equal to 7. Okay, so first thing we're going to do is subtract 4x from both sides. So then we have 3y less than or equal to 7 minus 4x. Okay, we're going to divide both sides by 3. So then that's y less than or equal to 7/3 minus 4/3 x. Now, 7/3 is not a good point to graph the y-intercept. So at this point, I would actually recommend using Desmos to graph this. And if we're going to graph this in Desmos, let's go back and graph this in Desmos, okay? So let me go to Desmos. All right, so let's graph in calculator. So let's graph. I'm going to go back and graph. Let's see. No, I'm going to graph y. You know what? Let me go back and graph the original inequality so that way I don't make a mistake. And surely they have inequality symbols, so greater than 2. Okay. Now they're using red, but nonetheless, that's okay. All right. And then we can check our points in a second, but now let's graph 4x plus 3y and then less than or equal to 7. All right. Now we need to find points that work for this graph. So I'm looking, that doesn't work, that doesn't work, that works. So that point is 4, negative 1, 2, 3. So let's graph that point. 4, negative 3. So, okay. So 4, negative 3. And we only need 2 points for the line. So let's find one more. That works. That doesn't work. That doesn't work. That doesn't work. That looks like that works. So that's 7, negative 1, 2, 3, 4, 5, 6, 7. So 7, negative 7. So see 5, 6, 7, negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6, 7. And let's just get another point just to make sure. Let's go this way. So then that doesn't work. This point looks like it's good. So that's 1, 1. So let's graph 1, 1. Now the slope is negative 4/3. So if we got the right points, technically if I go down 4, I should go there. So down 1, 2, 3, 4 to the right 1, 2, 3. That works. Down 1, 2, 3, 4. So there's where I made a mistake on the point. So down 1, 2, 3, 4 to the right 1, 2, 3. This point should be right here. Okay, that's why you want to make sure you double check what you're graphing with the computer. And so now we can go. We know that negative 4/3 is equivalent to 4 divided by negative 3. So for the next point here, we can go up 1, 2, 3, 4 to the left 1, 2, 3. Okay. Now we have our points. There's a line underneath, so it's a solid line. Okay. Now this one is now we want to go to here. It's going back to the y less than. So this is less than, and you might even check Desmos. You see it shading below. So we know that we're going to shade below. So one of the things I just learned is green and yellow don't really work well with the overlap. Okay, so I'm not going to use green. And so if you're going to buy a highlighter, your best bet's probably yellow and pink. Those seem to work better. I thought green and yellow were going to work, but they really didn't. All right. So let's go back to Desmos. Verify this and this verify. So, and this really. All right. So you kind of ignore that, and I guess if I want to, if you ever make mistakes, I recommend the Bic whiteout because you can go like this. Ooh, maybe I shouldn't recommend Bic whiteout. It usually corrects mistakes. And so here, there we go. And then we can color this in yellow. And there you go. Bic whiteout, save the day. All right. Now, it says it wants two solutions. So basically, any point in this Arden region is a solution. So let's pick 2 points. So let's look at 1, negative 1, 2, 3, 4. 1, negative 4 is a solution. So 1, negative 4 is an option. And these are just, you can pick more than that, but I'm just picking some. Now, negative 2, 1, 2, 3, 4, 5, 6, 7, 8. So negative 2, negative 8. And really, anything in this orange region you could pick and it'd be a valid solution, okay? All right. So if we would go ahead and finish up example 2. All right. Let's take a look at example 3. All right, solve systems inequality, general, page 23. Graph the system of inequalities and then select the coordinates of 2 points in the solution set. So again, before we can graph this, we have to solve for y. So let's come over here. So we have 4x minus 4y less than or equal to 12. All right, so we're going to subtract 4x from both sides. So then we have negative 4y less than or equal to 12 minus 4x. Divide both sides by negative 4. Or I should say divide everything by negative 4. So then that becomes 1. You have y. You divide by negative, this flips. So this now becomes y greater than or equal to 12 divided by negative 4 is negative 3. And negative 4 divided by negative 4 is a positive 1x, which are immediately going to put divided by 1, so we have the slope, which is a fraction. So to graph this, we start at negative 3. So 0, negative 1, negative 2, negative 3. Okay. And the slope tells us we go up 1 to the right one. So up 1 to the right one, 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 up 1 to the right one. And we know we can go down 1 to the left one, down 1 to the left one, down 1 to the left one, down to the left one, down to the left one. We know that this is a solid line. Okay. And we know that we're shading above because it's greater than. Okay. So this one we're going to shade in yellow. And hopefully you're not using a green highlighter because we discovered in the last example that green really doesn't work well. Okay. Now, what you might do is go to Desmos and let's graph that. Now, I'm not going to graph the one I solved. I'm going to graph the original, so they should, if I solved it correctly, they graph correctly. Okay. So let's just check some of our points. 0, -3, that works. And let's look at 1, -2. 1, -2 is correct. 2, -1. 2, -1. So this is lining up with Desmos, so we're okay. All right. Now let's solve this. So 4x minus 4y greater than -5. Okay, so we're going to subtract 4x from both sides. So then you're left with -4y greater than -5 minus 4x. We're going to divide both sides by -4. Okay, so when you divide by negative, this inequality flips. You get y less than, a negative divided by negative is positive, so 5/4. A negative divided by negative is a positive, so plus, and 4 divided by 4 is 1, so plus 1x. And we're going to immediately divide that by 1. Okay, now, when your y-intercept is not a whole number, I don't recommend graphing without a calculator. So let's go ahead and graph with Desmos, okay? So we already have that one. Now, when I graph it, I'm going to go back to the original, 4x minus 4y, and then greater than -5. Wait, that should be a negative. Okay. All right. So now let's find some points. Let's see. That's not a good point. That's not a good point. Let's see. Let's go down this way. Not good, not good, not good, not good. Surely we can find a good point. Not good. Wow. Not finding any good points this direction. Wow. All right. So this is what we're going to have to do. Okay. Our y-intercept is 0, 1.25. We're going to have to kind of approximate the graph. So 1.25 is right there. Again, we're just approximating. And then let's come over here and come on, give me that point. Follow along until I get a decent point. 2, 3.28. Oh, here we go. 2, 3.25. That's probably going to be the best we can get. So 2, 1, 2, 3.25 is about there. Okay. And now there's no line underneath, so it's a dashed line. Okay. Now, when it's shading, you have to solve for y for the shading. So now it's saying y is less than, so we're shading below. And if you want, you can go back to Desmos so you can see they're shading below as well. Okay. So again, I'm going to shade this in pink. And again, this is why I really recommend using two highlighters. Now, especially pink and yellow work the best, is you can see the overlapping region, which here is your solution. Okay. So solutions, we're just going to pick 2. I mean, you could pick more than that if you want to. It looks like 0, 0 is a good point. Is a solution, and 2, 1 is a good point. And again, you can pick anything in this shaded region. Okay. All right, if you would, go ahead and finish up example 3. All right, now let's take a look at example 4. All right, solve system of inequalities, journal page 23. Example 4, graph the system of inequalities and then select the coordinates of 2 points in the solution set. Okay, so again, we need to solve this for y, so 4x minus 4y greater than or equal to 12. Okay, and then 4x, so now we're going to subtract 4x from both sides. So then you get negative 4y greater than or equal to 12 minus 4x. Divide everything by negative 4. So then that becomes 1. You get y. That changes. It was greater than, but you divide by negatives. This becomes y less than. 12 divided by negative 4 is negative 3. And negative 4 divided by negative 4 is a positive 1x divided by 1. Okay? So we start at negative 3. So negative 1, 2, 3. Okay? And so we know we go up 1 to the right 1, 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 up 1 to the right 1. And we also know we can go down 1 to the left 1, 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 down 1 to the left 1. Okay? All right, now there's a line underneath, so it's a solid line. It's less than, so we shade below, but let's go ahead and use decimals to verify that. And again, I'm going to go back and I'm going to type in the original inequality, so 4x minus 4y greater than or equal to 12. Okay. So the shading looks below, so we're good there. And let's just check a few points. 0, negative 3, that's good. And then 1, 2, 3, 0. 1, 2, 3, 0, so the points are good there. Okay, so I'm going to shade this in yellow. Okay. Now I'm going to change this problem a little bit. I'm going to change that 5 to an 8. Okay. So we have 4x minus 4y less than 8. And the reason I'm doing that is on the last example, example 3, I had the 5 there so you could see what happens when you can't really find a good point, graph it. But in this one, I want just a good point that we can graph, okay? So we're going to subtract 4x from both sides. So then you're left with negative 4y less than 8 minus 4x. Divide everything by negative 4. Okay. A negative divided by negative is positive. 4 divided by 4 is 1, so that's y. You divide by negative, so this was less than. Now it's greater than. 8 divided by negative 4 is negative 2. And negative 4 divided by negative 4 is a positive 1x, which we're immediately going to divide that by 1. Sorry, let me start my pencil there. So, you know what? Let me change that to a negative 8. So it doesn't change much in the problem, but it's going to make the graph a little bit easier to see. So what changes that is a negative 8 divided by negative 4 is a positive 2. Okay. All right. So then now we have a point at 2. Okay. And we go up 1 to the right one. So up 1 to the right one, 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 up 1 to the right one. And we know we can go down 1 to the left one, 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 down 1 to the left one. Okay. Now there's no line in these, so that's a dashed line. Okay. And then it's greater than, so we shade above. But let's go ahead and graph this to verify that, okay? So that's 4x minus 4y less than negative 8. All right, so it verifies we shade above. So let's do that. Okay. Now, here you see that they do not overlap. When the regions don't overlap, we say that there is no solution. Okay. So if you would, go ahead and finish up example 4 and have a wonderful Wildcat day.